to our sponsor today.
Thank you very much.
So this was a very informative and exciting presentation, which gave us a good background of what big data is all about and what we're using it for. And I would like to now introduce our keynote speaker today, Jeff Jonas, an IBM fellow, one out of only 12 fellows, chief scientist, entity analytics. The floor is yours.
Thank you. I'm one of 72 fellows, just to get the statistic right, but 12, 72. I'm on 6 hours of sleep in 3 days. I caught myself a little cold. I feel like crap. So if I don't know what happens next, but I'm going to give it a go. So let's go. A little bit of background about me. I started my first software company when I was 17, and I bankrupted it when I was 20 and moved into my car. I started my next software company from my car, where I was living. Your business cards don't have an address, by the way, at that point. That company was called Systems Research and Development. That company grew up. I moved it to Vegas in the early 90s. I spent 10 years building systems for the casinos. Half the casinos in the world today use one of two systems that I built for the casinos. One of the systems I built for the casinos was used to help bring down the MIT card count team. So if you've read the book Bringing Down the House or saw the movie 21, the software I wrote helped bring those little bastards to their knees. They weren't really bastards. But if they can figure out that you have an advantage on the game, the casino can ask you to play across the street. They thought it was the facial recognition, which I was the first to implement in 1996 in a commercial setting, but that was a big, fat lie. Turns out to catch clever people, you have to have some data they don't know you have. The other technology I built for the casinos became known as NORA, or Non-Obvious Relationship Awareness. When you can lose $250,000 in 15 minutes, why would you want a batch job? You wouldn't. So this system took 18 different lists of bad guys and took everybody applying for credit, everybody making a hotel reservation, all their employees, their terminated employees, people applying for jobs, because you want to see who's trying to climb over the fence. It was used to help figure out who was related to who, so they could send them to the competitors. This technology ultimately caught the eye of Incremental. It's the venture capital arm for the CIA. I was taking my NORA technology to Washington. I was trying to sell it, but no one in Washington, D.C., nobody in defense or intelligence wants to work with you if you're a dude like me who lives in Las Vegas. It doesn't make no sense. So I took a little bit around the funding from Incremental. It was before 9/11. It was January, that funding was in January of 2001. And what we started doing with this NORA technology, we started finding relationships between the bad guys and the workforce. And so when Incremental came, they just said, we'd like to use your software in government to find criminals in government. I'm like, yay. So then I hired a CEO to run my company. His very first big decision was to tell me I was not a very good chairman of the board. I demoted myself to vice chairman. They grew the company up. We took another round of venture capital. Over my whole career, I've personally designed and architected and deployed roughly 100 different systems. At least 10 of those systems are in the multi-billion record, multi-hundred million person category. And today what I work on is how can you make more sense of data while it's happening so you can do something about it while it is still happening. And how can you make more privacy and civil liberty protecting features into it at the same time to reduce the risk that it gets leaked or it's used inappropriately. Okay. Now, I'm still alive. I'm okay. If you shook my hand earlier today, I apologize already. The year's 2003. I'm at one of these intelligence agencies somewhere around Washington, D.C. I don't know much because I have no clearances. I'm talking to a counterterrorism intelligence analyst. Her name was Ann. I look at Ann, and I go, what do you wish you could have if you could have anything? Because I invent stuff. I just wanted to hear. She thinks about it a minute, and she says, I wish I could get more answers to my questions faster. It sounds like something everybody would want. It struck me so funny, I realized it was totally insane. It was really 2 moves to prove it was insane. I thought about it, and I looked at Ann, and I said, Ann, what if it's not a smart question today? What if you ask the question next week? Oh, it'd be a great question. There's a timing problem. She looked at me and thought about it for a second and said, that could happen. So then I asked her, what are the chances you can think of every smart question and ask every smart question every day? I'm not kidding you. She looked at me defeated. She realized that was impossible. You know what I should have been thinking? I should have been thinking, we're all going to die. Because her job is this counterterrorism job. And she's going to have to think of every smart question every day. But on a more practical level, this phrase pops into my head as a better way to describe the body of my work, the Nora work, not the other 99 things. Every time a new piece of data arrives in the enterprise, you just learned something. It turns out the data is the question. You're not waiting for humans. This is what I call the data finds the data, and the things that are relevant find you. You're a bank. You discover criminal activity. You realize that one of your customers is going to jail, but you're sure that one of your customers is working with one of your employees, but you don't know who. 6 months later, one of your employees changes their emergency contact phone number in the payroll database, and it's the same number that's in the investigation. Do you think anybody in the world can see that? And the answer is no, they can't, unless they're playing this game where the data finds the data. It means the moment somebody changes their emergency contact phone number in the payroll database, if that puzzle piece lands right next to another record that is where there's an investigation with the same phone number, that would be very interesting. Now, it turns out this is getting harder and harder to do because as computers have been getting faster, organizations are actually getting dumber. Here's what's occurring. The amount of data that's in your observation space is growing on one curve, but your ability to make sense of it hasn't even been remotely keeping up. This gap is widening. I call it enterprise amnesia. I'll tell you, this word amnesia means forgetting what you know. It's like you're an organization. You have the red puzzle piece in this hand, you have the blue puzzle piece in this hand, but you don't realize they're related. So you miss the obvious. My favorite example, we did some work for a very large retailer. And we analyzed their data, and here was our discovery. 2 out of every 1,000 employees that they hired had already been arrested for stealing from them at the same store. This is a beautiful example of enterprise amnesia. And it's on the rise. You know, something bad happens, everybody goes and looks in their piles. Somebody goes and looks in the yellow puzzle piece pile and finds the 2 pieces. Somebody else looks in the blue puzzle piece pile, finds their pieces. You have to go meet with the boss with the 4 pieces. And it's very embarrassing because it proves the organization knew. Now, the question is, how come as computers are getting faster, we haven't even remotely been able to keep up? I did a blog post about this. It's called Algorithms at Dead End. You can't squeeze knowledge out of a pixel. Huh? What do I mean? If this is the only piece of data you have, it's like a puzzle piece. If they just enrolled in a newsletter because you're an insurance company, so all you've learned is the email address, you could use all of the computers on Earth. You could use an infinite amount of power and time. And what is your ability to predict whether you should sell them something or shoot them with a laser from space? There's a problem. You can't with any accuracy, and the reason is you lack context. And when I say context, I want to define this very specifically. I mean better understanding something by taking into account the things around it. When you see the word bat in a sentence, you look at the words around it to know what kind of bat it is. That's context. When I think about context in data, I think about every record in the enterprise as another puzzle piece. One of those is the human resources database. One of them is the references that they use on their employment application. One of them is a customer record and a reference. And here comes this record right here. And before you decide what to do about the yellow puzzle piece, you first figure out where it fits. With this much richness, you could use an original 1983 IBM PC and make a higher quality prediction about risk or opportunity than using infinite compute staring at the yellow puzzle piece. How's my speaking speed? Do you mind if I talk 10 times faster so I can finish quicker? Damn you. Okay, I will press on. It turns out this puzzle example holds up so well. I study the way people put puzzles together today, and it inspires me on the algorithms that my team and my engineers and I work on today. I've done 4 puzzle projects, 2 with kids, 2 different projects with adults. I want you to imagine this for a minute. In the middle of the room here is a giant pile of puzzle pieces. You don't know if it's 50 puzzles or 500 puzzles. There's no box with a cover. There's no edges. You look at it, there's clearly missing pieces. You look at it, there's obviously duplicates. Some of the pieces have errors. And you're even told that some of the pieces are professional lies. until you start taking those puzzle pieces from all those different kinds of systems and all those different colors and putting them onto the table to see how they relate. You don't know what you have. You don't have the real picture. So I bought 4 puzzles. This was my first project. But I hid 10% of the first puzzle, a third of the second puzzle, I hid 50% of the next, and then I kept a few random pieces from the fourth. And because I have a dark side, I bought a copy of the first puzzle. And I took 10% of these pieces and made a pile at my girlfriend's house on her kitchen table. She had a barbecue. I told them nothing. They see a pile of puzzle pieces. They think it's a normal puzzle project. It's not. My girlfriend sees 3 cousins and her son. You know what I see as a technical guy? I see 4 parallel processing pipelines. Can you see it? You could even estimate how many parallel processing pipelines you could even get around the table. 8 or 10. Okay, then it would max out. These are the first 2 pieces of data that found each other. Here is more data, it's finding more data. Here is a duplicate. At this point, they don't even know it's possible until they found that piece there and stacked it up on top. Because it was an unknown that you could have a duplicate in a puzzle. But the puzzles began to take form. They started at 6:40. 22 minutes in, they said there's a duplicate. 35 minutes in, they realized some pieces were missing. 37 minutes in, it says it looks like a bunch of hillbillies on a porch. I want to explain hillbillies. Maybe half of you know, but these are people that live in the mountains. They make their own alcohol. They have no teeth. And their family tree goes straight down. Oh yeah, it turns out everybody's got, you guys have hillbillies? Yeah? Okay, well it turns out lots of places. I was in Russia, you know, blah, 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 and it turns out they got some hillbillies. A few minutes later, they add some more pieces. And they realize it's hillbillies playing guitar, sitting on a porch near a banjo. This is all they could see. Underneath that bowl where they were collecting some sky, and underneath the bowl where they were collecting some grass, is the barbershop sign. Under there is a guitar, a porch, some boots, off to the right, a banjo. This is the puzzle that I denied them 50% of the observation space. In every project I've done with less than 50% of the observation space, 50% of the pieces hidden, in every project I've done, if you give somebody just a random 50%, you can make an extraordinary, accurate prediction about the overall scene. I find this inspiring. 47 minutes in, they realized no matter how much compute they were spending to make more sky and grass fit together, they could have connected some more, but they realized it wasn't helping them understand the scene. So they self-optimized. 2 hours in, the oldest, she was 17 at the time, said, let's switch. This was difficult, by the way. It was hard. They were struggling. But the oldest female says, let's switch sides and see if we can make sense of this from different perspectives, which I'm like thinking, that is genius. They realized there was 3 puzzles, no 4. They realized you needed a bigger table to put the 3 major puzzles on it. I think you threw in a few random pieces, and then a few minutes later, the oldest boy just looks at me and says, you're evil. And I just want you to know, it was a great day. Like, I am not kidding. I thought to myself, this is possibly the greatest day of the year. That's what I thought. Now the puzzle, this was the puzzle that had only 10% of the pieces missing. Now it turns out how context accumulates every new piece and where it fits is so close to the way you put the puzzle together at home. I want you to see this with me. You get the next transaction in the enterprise. It's just like just grabbing in the box and grabbing the next piece. You look at the puzzle that you've been building and you make only one of 3 decisions. You're either not sure really where it goes, so you put it anywhere. Or it's like the red and white pieces, so you cluster it and put it near the red and white pieces. Or it connects to something, and you snap it in. And at that moment, you've done the most you can do. If you're going to learn something, you just learned it, and now you're ready to go on to the next piece. When you connect pieces, you only connect them when you're sure. I live in Vegas. There's another Jeff Jonas that lives in Vegas. If you just see 2 Jeff Jonases in Vegas, you can't assume it's me. You have to favor the false negative. When's the last time you put a puzzle together at home and said, it doesn't fit so good, but with some glue and a hammer, I can get that little bastard in there. A funny story for you, my 4th puzzle project was with drunk adults. And I only learned one thing. Sometimes drunk people are unreasonably optimistic. Because the drunkest of them all was actually pounding the pieces in. I was drunk too. It was very hard to record the whole events, but I do recall trying to run behind this girl and disconnect. That's not important now. I might have a temperature. Okay, we're okay. This is fundamentally the single hardest thing to do. It's the single most important thing to do. Sometimes new observations reverse earlier decisions. You didn't think the two pieces were related. You found a new piece, and it's the glue that brings them in. Or you did connect two pieces you shouldn't have, but as you continue to put the puzzle together, now and then you stumble upon two pieces that you really shouldn't have put together. So you take them apart. Imagine a system that has billions of puzzle pieces, and you've made a billion decisions, and now today you get piece 1,000,001,000. Not only do you have to figure out where it goes, you have to ask yourself, had I knew that puzzle piece in the beginning, over the billion decisions I've made, had I known that, should I have made any of them differently? Bless you. Doing that in real time, over billions of records and hundreds of millions of entities at thousands of things a second, figuring out where something goes and fixing the past is non-trivial. 20 years in this business, it was so rare. It was causing data drift. Weird things were happening in audits. It took 20 years for me to realize this phenomena. And then I've spent the last 10 years trying to optimize these algorithms to just see how fast you can make it. It is truly the hardest part. Some observations produce big new discoveries. Maybe the puzzle piece is just blades of grass, just grass, it's nothing. But it's the only piece that connects two scenes. That piece gave you something new to tell you these two scenes were near each other. Some of the organizations that would use my system might go buy phone books, whole phone books. 100 million records of name, address, phone from somewhere. How valuable are those? They're not. It's just phone books. But it's possible that one of those records, the address is one of your employees, and the phone number is somebody that you're trying to keep an eye out for. That one record is magic. The emerging picture helps change your collection interest, what data to load next. You see this at home when you put a puzzle together. You're putting the puzzle together, and pretty soon you're like, I'm just going to look for the edges. You're not just getting any piece. Or there's a bunch of red and white pieces, and you don't want to just wait any longer. Instead of just getting the next piece, you go to the puzzle and look for just the red and white pieces. My customers that bring data together, there's a point where you get lots of maybes. The way you fix maybes is not more math. The way you fix maybes is you say, what kind of data would be worth pouring in next? Much like the puzzle at home, causing things to snap together. And in fact, this is the single most exciting thing I've seen in context accumulating systems at scale. If the puzzle's going to be this big, can you put it together on a table this big? Not so much, because it puffs out. In fact, the most expensive piece is when the puzzle is puffed out to the most, and you get the next piece. There's so many places it could go. You're going to use the most compute. But if you have enough puzzle pieces, you get to this tipping point where you get some chunks, and the chunks start to fall in, and you get some edges, and it starts to collapse. Isn't it interesting, as you're putting a puzzle together at home, even though you're getting more puzzle pieces on the table, as the puzzle begins to collapse in the amount of space it takes, it's your confidence about where the data goes, where the piece goes, and the speed with which you can place the piece gets faster and faster. So I saw this for the first time in 2006. My customer had 50 billion records. It was not a government. They were a data record aggregator in the U.S. They just collected whatever they could get. All the phone books for years. Everybody that owns property for years. And voters and stuff. And they asked me to help them with something. They said, we want to discover invented identities. Not people that stole an identity. Invented identities. You know, if you steal an identity, at least somebody can complain. But what if you invent one? Who's going to complain? So what I said is we're going to eat these 50 billion records, and if it's about the same person, we'll put it in the same folder. And then we're going to see how thick people are. What do I mean? If somebody's 37, and they've never voted, never driven, never been in a phone book, never owned a piece of property, only been in one credit bureau for 6 weeks, it doesn't mean they're criminal. But if you're trying to focus limited resources, that would be the place to start. So here's what happened. This is the U.S. population, this green line, 300 million people. We're eating puzzle pieces. And as we're eating puzzle pieces, pretty soon it says there's 200 million people in America, 300 million, 400 million, 500 million. I was freaking out. What's happening is it doesn't know these two people are the same. They're turned into 3 of me in Vegas. One at my home address, one at my post office box, one at the IBM address. There wasn't enough evidence to say it was one person. So you're over-counting the number of people because there's not enough evidence to put them together. But it got to 678 million people in the U.S. And as new puzzle pieces landed, you realized it wasn't 2 Jeff Jonases or 3 in Vegas. They would all snap together and become one. Because a record like this would show up that has enough features from both, which would cause these 2 folders to collapse. What was happening is it was getting more accurate and faster. It was fascinating. This has a huge ramification for big data and how to choose which data to load next. It inspires you on how to cause this function. So this leads to what I call big data new physics, where you get more, usually you're taking algorithms and you're fighting the false positive, false negative war. I did a blog post about this called Data Beats Math. Context accumulating systems where you add more data, the false positives and the false negatives both go down at the same time. Another fascinating thing is the bad data starts to become your friend. You start to be glad that you didn't over-clean the data, the misspelling errors, the dates of birth with the month and day transposed or 1 digit off. You start to be glad that you kept it. Here's a place you have seen this. When you search Google and it says, did you mean this? Have you experienced this? Yes? It's not looking in a dictionary. Google is remembering everybody's errors. If it didn't remember the errors, it would not be so smart. And my third and final, what I call, obviously I don't mean real physics, I just mean an unexpected thing happens when you go from piles of puzzle pieces to context accumulating systems. The more data you get, the less compute you need. It takes less CPU. As that curve was coming down off of 678 million, the accuracy was going up and the amount of compute, CPU needed, was decreasing. Because here's why. A Jeff Jonas shows up. At one point there's 3 of me in Vegas, so you have to check 3. Later when 3 Jeff Jonases become 1, when you get a new Jeff Jonas, you don't have to check 3 things. When I explain this to my mother about how this could be, I say the following. Why is it when you put a puzzle together at home, the last few pieces are as easy as the first few when you have more data in front of you than ever before? It's exactly the same principle. Now, by the way, I've always been saying the last few pieces are as easy as the first few. So I took a different set of kids, I put them on my boat, and I took them out to sea. And we have a thing called Child Protective Services in the U.S. Yeah, miles away from them. No food, 5 hours, me and a stopwatch. Evil. I timed it. It turns out the last few pieces, the last few pieces are not as easy as the first few, but they're nearly as easy. It was about 25% of the way in is where that puzzle took the most space. And after 25%, the compute time and the accuracy was increasing. It's really, I think it's really, really interesting. So there's a big difference between a pile of big data and data in context. And one of the first forms of context is knowing if it's the same. Is it 5 people, each with 1 call, or is it 1 person with 5 calls? Is it 20 cases of H1N1 in 20 cities, or is it 1 case reported 20 times? If you can't figure this, I cannot tell you how many organizations are trying to do pattern discovery or visualization, and they haven't done this. You absolutely have to figure out when you have discrete entities. I have an example for you. One of the terms of art is entity resolution. I have an example from work I do in voter registration. Here's a voter. There's a dead person. You're trying to keep the dead people dead. The only data that's the same is the name and the year of birth. That's not enough. You'd have to give this to a human. There's too many maybes. You're not going to hire that many people in the U.S. population to do all of these. But our election offices have access to our Department of Motor Vehicle data, DMV. And when you see this record, let's say because of the middle initial F, it snaps into the voter. Now there's so many features in the voter in the DMV. The name, the year of birth, and the tax ID, the Social Security number. Machine speed. The moment the blue record shows up, the dead person snaps in. No humans. And if you were to look at the dates and stuff, my last paragraph on the right, you discover that George, who died in 95, voted in 2008. Huh?
Resurrected.
It's what?
Resurrected.
Resurrected, yeah. It's only legal in 3 states to vote when you're dead. Okay, that's a lie. That was my first actual lie. Now listen, expert counting comes in different degrees of difficulty. Here, same name and same national ID in the lower left. Easy. Fuzzy, 2 N's in Jones and some leading zeros. Bob and Robert. Trivial. I've spent a few decades solving the top 2. There's no lies, but the features are incompatible. How do you know it's the same person? And what if there's somebody named Ivan that's running Bob and Ken at you? Ivan has created 2 identities, and it's him. How would you know? If this is the only piece of data you know, you'll never know there's a lie. It takes more puzzle pieces. But let's imagine for the moment what could happen. You might be able to take that name and date of birth of name and national ID of Bob Jones and find a post office box and date of birth. And maybe on the right side you could take Ken Wells and that national ID and find a record with a date of birth, a different post office box, and an email address. Now both sides have the same date of birth. Oh goody. That happens a million times a day. But now you find another piece. You find an email address for this guy on the left, Bob. Now both sides have the same email address and the same date of birth. This allows you to get to a place where you could start to make an assertion. Add things like a device fingerprint or some geospatial data, and you could assert in real time, these are the same people. So this is accumulating features, and as these puzzle pieces arrive, things collapsing. You know, I don't just catch bad guys, but it's some of the most fun I have. You know, I could go like, yeah, we could market, and then make sure you don't give me an ad for shampoo. Oh, yay. But chasing bad guys is really much more fun. Bad guys use channel separation. Only the idiots in a single email go, Ken and I are going to buy some diesel fuel and fertilizer, go down to the embassy on Thursday, and blow it up. These idiots run out of gas on the way to the operation. We don't really have to worry about them. But the question is, what about the clever bad guys? They don't want you to realize that the person that had this transaction is the person with this. And you can't catch the weak signal unless you can figure out how to do this. They're trying to deny you to do that. By the way, you use channel separation too. If you sent me a spreadsheet that was encrypted and then called me with the password, that's channel separation. Somebody trying to pierce that needs to be able to consolidate the channels. So it turns out in data, whether it was the MIT card count team or counterterrorism work or stuff I do for looking for money laundering for banks, there's only 2 ways to use data, just data, to catch bad guys. There's only 2. Method 1, you want to have some data they don't know you have. If they know you have cameras on 3 streets and you tell them, they'll take the 4th street. Now sometimes the bad guy has studied you so well or recruited somebody and they told you, or they've overestimated your data. Then there's only one other way to catch them, the clever ones. You have to be able to perform compute on the data in a way that they can't even imagine. I'll give you a simple example. They know you have a camera in the parking lot, but they never got the memo about license plate readers that can read the license plate off of that, right? That's performing compute on that data. So after IBM buys my company and the NORA technology, they renamed it to something unspeakable. A few years, then I never mentioned it publicly, ever. And then they upgraded it to this a little while ago, which was slightly better. Now listen, I like to keep reinventing what I'm doing. My main job is to just invent new stuff that's real useful. So I got to thinking, how is it that people figure out when things are the same? How do you know it's your car? How do you know it's your friend? And I used to think that the way you would know it's the same person is you would, in the data, you'd look at the name and the address and the phone and the date of birth. And how do you know if it's the same car? Hey, the make, the model, the color, the license plate. But then in my head, because I'm curious and like to experiment, I imagined 2 identical twins. These 2 ladies are sitting in 2 chairs. I didn't know how to draw that. But these are 2 ladies dressed in the exact same outfit. They're identical twins. They're sitting in 2 chairs. And they both look at you. I was imagining this, and they go, we are one person. And you're like this. And then, to prove it, they both give you exactly the same passport. They go, see, we're one person. Then you check fingerprint and iris and DNA, and everything tells you, oh no, it's okay. It's one person, but you're like this. Then you ask your most trusted source, your best analyst, or I ask my mother. or the clouds part and supreme beings come down and tell you. How come? I was thinking about this. I'm like, what am I missing in my work? How could this be? All of the features are the same. All the evidence you have, what am I missing? And now it's rather embarrassing. We have this physics principle baked into us. The same thing can't be in two places at the same time. As more data comes online about where things are, it turns out geospatial data is going to be analytic superfood. Do you know this word superfood? Really, really healthy for you. Now, I realized then the opposite principle is the same. If I covered myself with a sheet and then I used a voice changer, so my height's changed, different feature. Then I change my voice and I go, my name is Susan. You wouldn't be fooled, even if you checked my fingerprint before and after. And it said, oh, they're different. It would be this principle here. You'd know it's still me. So I went from thinking that to realizing where and when are absolutely the highest order bits. I've become obsessed with this geospatial data. I then got thinking back about my voting project. These two states, Washington and Oregon, are so close you could drive between them and vote. Here's a name and a date of birth. Is it the same Bill Smith? Who knows? Just looking at 10 years of address history, just roughly, not high precision 19-meter data, just generally, where's these Bill Smiths been living? Just with these life arcs, you could make an extraordinary, accurate claim that these are different people. You know this word? Oh my God. I have seen a lot of data. I don't have any myself, but I get close enough to my customers and help them solve problems, and I don't get surprised by data often. But I ran into something about 5 years ago that blew my mind. I swear to you, I woke up every single day. The next day, this is for 6 weeks. I woke up the next day and went, wait a minute. If that means that, then that would mean this. And then, yay! And then I'd wake up the next day and go, whoa! Then that would mean this. And the next day, it was crazy. If you can't tell, I became obsessed. I'm going to tell you what it is that I learned. I went to a think tank. It's called the Aspen Institute up in the hills, and there was a big data session, and they brought, 15 or 20 people to sit and have thoughts about big data. One of the people that was there, I call it space-time travel. It's about the cell phone. This guy sitting across the table from a company I've never heard of. It's like a startup. He said, did you know in the United States we produce 600 billion records a day about where we are when? Even with GPS off, 3 antennas, plus or minus 60 meters. With GPS on, 20 to 30 meters. With Wi-Fi on, sub 10. And I'm thinking to myself, okay, fine. That's a lot of data. Then he said, I'm getting 85% of all of it for free. In real time. It's not like it's free for everybody. He made a deal. He said, give me the data, we'll do some analytics. Huh? And if we can figure out how to sell it, we'll cut a deal and we'll share the money. So I'm staring at this guy that's getting 85% of this data, and it's de-identified. You don't know who it is. So he says, hey, I don't know it's you. But, he says, I can see plus or minus 60 meters where you spend most nights. Let's call that home. He goes, I can see plus or minus 60 meters where you spend Monday through Friday to 5. Let's just assume that's work. He said, you tell me 2 or 3 places you frequent and I'll find your spaghetti noodle. You know, I just vision it like a giant ball of spaghetti. You tell him where you go a few times. He's like, oh, this one's you. He shows me a heat map of New York. We had the big financial firm called Bear Stearns that collapsed. It's tragic. They collapsed on Saturday. He showed me the heat map from Friday night about how many people left Bear Stearns and which bar they went to in a mob. He said to me, I can watch, he named a department store, I won't name it now. He names a department store and he goes, I can tell you how many people go and how long they stay. And I'm like, wow. And then he says to me, that's nothing. And that's basically when OMG is like bouncing around in my head. I'm just like, he goes, I can tell you that people used to travel 27 miles from these neighborhoods. to go to that store. And it's been changing every week. And now people only travel 22 miles from these other neighborhoods. I can see it so close to real time before they produce their public quarterly earnings. Oh. It's just, what happened in my brain next is just, I probably had to lay down and suck my thumb in a baby, fetal position. 6 weeks. Then he says to me, I could tell you the 10 people you spend the most time with. Not at home, not at work. I thought if there was a name on there I didn't recognize. Huh? He's following me. You think like that if you spend a lot of time catching bad guys. It turns out the space-time travel data about how we move is like a biometric fingerprint. Think about where it is that you live and your course over the ground to get here to the university or to get to the office. It's going to create all kinds of really great opportunities. It's going to make it really, really hard to have secrets. It's going to change our ideas even about what privacy means. And it's being adopted at a blistering pace. When I first saw this, I was like, wow. And then as I travel around and meet people in London that are putting up passive antennas in shopping malls, not even with the telco, just watching how phones move so they can do time motion studies. Another group's putting antennas up at prisons and doing X, Y, Z to tell you where there's a phone in the prison. Not only which cell and which bunk, but which end of the bunk. I thought it'd be a good time to pause for a minute. What time is it? How are we doing? Where am I at?
7 o'clock.
Okay, I can live. You ready for a little more? I don't even know what chart's next. I kind of whipped it together on the way over. Ha! Okay, we had a theatrical pause, kind of like part 2. You had a little chance to go to the bathroom? Not? Okay. 5 years ago, another executive at IBM. So first of all, IBM buys my company in January of 2005. No one thinks I'll stay. But I've got no sales quota, I've got no budget, no one reports to me. I'm just having so much fun, it is ridiculous. No paperwork. I didn't even tell anybody I was really coming here. I mean, it's great. 5 years ago, another executive looks at me and says, if you had a big idea, we might fund it. And I thought to myself, if I could only build one more thing in my life, what would it be? So I dreamt this thing up, and I went to my boss. And I said, how would you like me to build IBM this? He was quite shocked, because my VC friends are like, why don't you quit and build it with us? I'm like, I'm not trying to make money now. I'm trying to be useful. So my boss says, well, how much? And I'm thinking, how do you even build something this big of an idea in a big company like an IBM? I'm used to small SWAT teams. So I don't know. I told him 50 million. But he said to me, he said, can you do it with 6 people? I said, can I handpick them? Can I run it like a czar, like a dictator? It ain't a democracy. And you can't sell it until I tell you you can, because I'm not going to damage my name that I've worked so hard for. And the deal is yes. So they promised me 6 people. The funny part is then they only gave me 2. They're bastards! But because you have to watch out for antibodies in big companies, I had them reporting to a secretary in the marketing department. Hacking the machine. One of the 100 systems I've built, plus or minus, one of the guys I picked, I've built 70 systems with. We have worked 24 hours at a time straight. I know what position he sleeps on when he has to sleep on the floor. I know what kinds of beetles he eats. I'm not kidding. I know when he's going to snap. He knows when I'm going to snap. We've been to war so many times. The other guy I picked for the last 8 years, he's been building the part of the algorithm that changed their mind about the past. That's the tricky part. The 2 of them worked secretly on this for 2 years. Didn't tell the world I was even working on it. 3 years ago, I even mentioned it publicly for the first time. So now it's been born. It's 3 years old. It's just 3 years old, so it has a lot of things that aren't as mature as my NORA technology. I mean, it still makes poopy pants. Does that translate? Yeah, it still makes some poopy pants, but it's really the right thing. A little bit about it. What it does is it evaluates each new observation, which is like a new transaction, like a puzzle piece, and it compares it to all the previous. So that's, where does the puzzle piece fit in the puzzle? And then it looks at the surrounding pieces, and it says, is that going to matter to anybody? And if so, to who? And telling somebody fast enough so you can do something about it while the transaction's happening. And then do it at significantly bigger scale. I hope that G2, my group now, by the way, my title's changed since we made the charts here, but I'm now the chief scientist in IBM of context computing. And I think this class of algorithm is going to be seen as one of the early, Gen 1 general purpose context computing engines. When I say complete context, it means it doesn't matter whether it's Twitter data or asteroid data. You can weave all the data together. Current context means it's current to the subsecond, to whatever it is that you've presented, milliseconds. Conflicting context means things that disagree. You have 7 dates of birth. G2 can tolerate that. It says you're related and not related. If 6 people know it's 1, it understands uncertainty, and it lets it bubble. And self-correcting context, which is the trickiest part, changing your mind about the past as new data shows up. I've designed it for cloud compute, not just cloud compute, but compute on grid, or shards, if you heard of shards. So if you have 1,000 shards and it's not fast enough, go to 2,000 shards, and it should be about twice as fast. You can introduce new kinds of data, like geospatial or voice templates, and new features, and new kinds of entities while the plane is in the air. No one ever invented Twitter. Somebody comes running in and goes, "You're going to have to eat my blue puzzle pieces." No changes to the database schema, minor few notations to announce to G2 what to expect, and it pumps into the blue puzzle pieces and weaves it in with everything. My goal is 200 millisecond sense and respond, so you can put an ad on a web page to make sure I don't get a hair care product. And I've been baking in these privacy features, which I'm really rather proud of. As much as I love to hunt bad guys, I spend a lot of time with the privacy community in the U.S. In fact, I sit on a board of a group that actually sues my government for overstepping our Fourth Amendment. It's tricky, because I really know some things, and I'm really trying to help catch bad guys. But at the same time, I really want to learn from them, because I want to engineer things into my algorithms that cause it to be not misused so often. I wrote a paper about this called Privacy by Design in the Age of Big Data. I baked 7 privacy features in. I'm just going to show you one of them. It's called self-correcting false positives. It sounds like a marketing statement because it's kind of catchy, but it turns out it's also technically accurate. That's funny. Oh, God. If you had... It's not really this trivial, but to make this a simple example, if you had a rule that said if the names are the same and the cell phone's the same, done deal. Same person, right? Same cell phone, same number. So you'd put those 2 observations into the same folder. Then this record shows up, but it says John T. Smith Sr. Now the cell phone's the same, but the driver's license is different. The moment that 3rd record shows up in real time, you want to realize that record 2 didn't belong there. The moment record 3 shows up, it's record 1,000,000,001. At that split second, it moves. This is really important, especially in targeting systems and watch listing systems. If you get a piece of evidence that says somebody should not be infringed, how long should you wait until you notice? Should you wait once a month when you reload the database? Or once a quarter? And nobody really wants to do that. As you get to big data, the idea of let's tear it down and reload. Excuse me? I've been using G2 in a few places. I've been helping the Singaporeans analyze data to help protect the Malacca Straits, half the world's oil supply, 30% of the world's commodities, mobility data about vessels. It's very exciting. I've also used G2 to help modernize voter registration in America. I'm also helping a big bank right now with hundreds and hundreds of anti-money laundering analysts that primarily look at false positives, how to fix that. Here's what's... Oh, and I'm also working on asteroids. This is important, because Earth is where we keep our stuff. I'm using a technique called a space-time box. They've only discovered in recent years that asteroids sometimes hit asteroids. It's very rare. It's only been seen twice. It's by accident. I've already created a 15-year forecast of all the asteroids, all 600,000 versus all 600,000 about where to look in the future. And we're going to run it out to 25 years. But here's a main point. Why G2 is so different is I could use it for maritime with the Singaporeans, voter registration in America, anti-money laundering for banks, and asteroids. And you can do it all at the same time in the same computer with the same database table schema and the same algorithms that weave the puzzle together, the exact same. That's really different. So I'm real excited about it. I work, massive hours. It's coming along. Closing thoughts. You want to wish enterprise amnesia on your enemy. Huh? You want to be blinded by overwhelming data and missing the obvious. The journey, I think, to fix this is really context accumulation. It's about how to weave it together. And what I've been doing and people have been doing is we tend to build algorithms for problems. Like, oh, the red puzzle pieces? Well, let's build some algorithms to study the red puzzle pieces. Oh, green? Oh, you have Twitter. Well, let's build a special set of algorithms just to study the blue puzzle pieces. This, I think, is now going to be the wrong journey. I think the future is going to be weaving this data together. And by the way, above the blue puzzle piece is a little blue box. If the blue puzzle piece is a video, maybe the little box there is a license plate reader. Okay? So it's extracting the features. So I don't care whether that's structured or unstructured. Can you get features out of it? Yes or no? If you can't, pointless. The better of a job you do doing data finds data for all mission, the easier it is to figure out what is relevant to who. And so my context computing work is all in this, how do you weave this general data. The most competitive organizations are going to make sense of what they're observing fast enough to do something about it while they are still observing it. I've been blogging on the topic. I just want to tell you about one of these blogs. I really should go because I just feel horrible, but I just got to tell you. This fantasy analytics, I wrote this one blog post because it's so true and it's so funny. Over half the organizations I go see, when they tell me what they want to do, like they want to use analytics to do this, and I ask them what data they have, I look at them and ask them if they are smoking crack cocaine. I'm like, not even a room full of divine beings could look at that data. And I had to take a couple of different customers to weave the story together, but here's the short story. Okay, from my story. Oh yeah. So I asked this organization, what do you do? So basically they go, we protect the supply chain. Great. What's your goal with analytics? They go, finding bombs. I'm like, oh, I love projects like that. Like I'm scooting my chair up. Tell me. Tell me about your observation space. They go, oh, we have who sends it. We have who is going to receive it, who drove it on the boat. Huh? And we have the manifest about what they said is in it. I'm like, yay, what else do you have? They go, that's it. I go, you will never find a bomb. No one writes bomb on manifest. It's like fantasy analytics. So in this blog post called Fantasy Analytics, at the very bottom of it, I have a little self-help section. And it's called Widening Observation Spaces. For half these organizations that don't have enough data to get an accurate analytic outcome, the thing to do is help inspire them about shifting that observation space, which might be data they own already or data they can buy. Okay. I'm not really going to hang out anymore. I suppose, and I answer every email from like everybody on earth. You send me an email, boom. Now, should I take one question or should I just get off here? Okay. Oh, you're fast. Oh, you. He probably had his hand up for like the last 40 minutes. Okay.
Can you say anything about the technologies that you've been using in the G2 project?
Yeah, so I'll give you the short version on this. My G1, which is my identity insight commercial grade. My biggest customers have like 100 terabytes of solid state just for metadata. It's running on an SQL database, okay? But that's about as big as you can go. Like you really have to get exotic to go bigger. So one of the reasons I had to invent G2 is I need to get to where if you get one box that's full, what if I said you need to have 1,000 of them? So what I've done with G2 is I've completely changed the schemas. Every table only has one index. It's designed for NoSQL row stores. You could run it on SQL, but it's a 30% disadvantage. I've been trying different NoSQL row stores. You can't really use Cassandra for a variety of reasons in this. The reason you can't use Cassandra is because it's eventually consistent, which means you have a system that says shoot, and then it finally catches up, and so 3 minutes later you have to say send flowers to the family. So I've been experimenting with different back-end NoSQL row stores, and we're just getting that scaled up now. So my G1 currently scales bigger, but G2 is going to eat G1. Okay. I gotta go. Okay, well, thank you.